Yeah, we crossed them.
The students work on two problems that examine the inheritance of body color and wing shape in fruit flies. They soon find that the data they generate are not quite what they predict.
Yeah. Let's try crossing two curves and see what we get.
Okay, so you get all curved.
All right. Let's go ahead then and try to cross two different ones, a curved and short one, and maybe just see, if we can find a dominant one. Oh wow, we have all waxy.
Wow.
What does this mean?
Okay, I guess
It must be that. There must be something recessive and hidden in the curved and the short.
What was the thing? I came over here and what did you say to me?
This is weird.
This is so weird, yes. That's called anomalous data. It's just, you can't use your current idea to explain that. So somehow you're going to have to change. There's parts to Mendel's model, aren't there?
Yeah.
Is any part sacred? No. You can play around with anything in that model and then see if it can help you explain this crazy where you cross two waxes and you get waxy wings, short wings, and curved wings. Basically what you need to do now is just start looking at that model and say, what can I change? And if I make such and such a change, how will that affect what things I'd expect to see?
I'm wondering if we have more than two alleles, like we've been dealing with just 1 and 2. I'm wondering if we have like 1s, 2s, and 3s, but still only 2 of them are carried.
we think ebony's dominant, so we can put ebony as a 1 and try it here.
1, 1.
Maybe like the number combination equals the color. Like a 1-1 could be like ebony. Like a 1-2 could be
Green.
green.
If ebony's
Maybe
dominant,
that's it.
then it would still show.
But
in
like,
this.
so ebony's like a 1, and with this one we have 1, 1, and then let's say this is a 1, 2, and the green like show, cause like you would get like a 1, 2 in it.
Yeah.
Oh.
So it takes like a certain combination to get the color.
If we thought that these were,
Like 1,
but we wouldn't get a green if ebony's combination was 1, 1,
yeah.
because you get all 1, 1, so you get all ebony.
Too.
Well, let's try to explain one of them that has the 3. Okay, a tan and a tan. What kind of number do we want to give tan to see if we can get 3 different outcomes?
Tan would have to be a 1-2 combination.
Okay, so that would make sense because then we could explain that the 1, 2s. We ended up with green, more green than anything else.
Yeah.
I guess we could say that part of that was chance, because then we would end up with these being tan still,
Yeah.
We got tan.
and either 1, 1. This would either be green or ebony, and this would either be green or ebony.
Yeah.
Should we try doing one that would give us 4?
Yeah.
What did we breed? An ebony and a green?
See, probably ebony and green, yeah.
You'd need
Okay, so this could be ebony.
and then 1,
and then-
3 has to be green, cause that's what we bred.
Okay. And then, what were the other 2 combinations?
Pallid and tan.
Pallid and tan.
Which makes sense because if pallid is recessive, it's probably going to carry 2 of the same.
And then this could be tan.
Yeah, that makes sense. Which would provide us that green is dominant.
Go back and find your wackiest cross.
Okay.
That'd be the 4, 1.
Yeah.
Green times ebony.
2, 2, 1, 3.
That's awesome.
1, 2, 1, 2,
2-3.
2, 3, 2, 3. That fits too.
Yep.
Ebony and green.
So that's gotta be it.
Yeah.
Sweet.
Good job.
Figured it out.
Awesome.
I tell you what, let's put up on the board some of the wackiest crosses that you came across. I mean, what was unusual? Tell us what was unusual about this phenomenon, problem 2.
We came up with this triangle theory, and we decided from the first couple crosses that we did that ebony was dominant and green was dominant, because when we bred ebony and ebony, we got ebony and pallid. So, and we got it in a 3-to-1 ratio, so we figured that ebony was dominant, just like green was dominant.
So that actually fit the Mendel model, didn't it?
Right.
Yeah.
So we used that in part of ours. But then we got some really weird crosses when we bred ebony and green. We ended up getting all 4 of them. And that's what this Punnett square is right here. So we figured out that green was a 2, 3, and that ebony was a 1, 2, and when we bred them, we ended up getting all 4 variations that fit on our model.
Where'd you come up with the 3? Why'd you add a 3?
Because there was no way that we could get 4 different color variations from just 2 alleles, because you only end up with 3 different combinations. So even if every single one of those was each a color, you still have one color that is coming from nowhere. So we came up with that maybe there was 3, but you only carried 2 of them. So you still can end up getting all different 4 color combinations from having 3 different alleles.
So what was the basic thing that people changed about the Mendel model?
Number.
Yeah, the number of alleles. You know, Mendel said, well, I think there are two different bits of genetic information for this trait in the population max. And they're basically saying, you're not going to get enough variation that way. Oh, I've got a wonderful question for you. If you've got 3 alleles, what's the greatest number of variations you could get with 3 alleles? Phenotypic variations.
9.
6.
Why?
There's 6 different.
Well, a triangle shows 4.
No, but if ebony was something else, like if ebony wasn't dominant, then you would have ebony, the 1, 2 could be another color.
Perfect.